Hello everyone, I am Devasish Dangar, working as an assistant professor in the Department of Mathematics and Humanities, Institute of Technology, in my university. Today I will going to discuss some introduction portion of operation research and formulation of linear programming problem. Before I begin my presentation, let us see what operation research is. Operation research is also called OR in short form, and it is a scientific approach to decision making which seeks to determine how best to design and operate a system under conditions requiring allocations of scarce resources. Operation research as a field primarily has a set or collection of algorithms which act as tools for problem solving in chosen application areas. OR has extensive applications in engineering business and public systems and is also used by manufacturing and service industries to solve their day-to-day problems. Now, next, some history background of operational research. The history of OR as a field goes up to the Second World War. In fact, this field war started during the Second World War, when the British military asked scientists to analyze military problems. In fact, Second World War was perhaps the first time when people realized that resources were scarce and had to be used effectively and allocated efficiently. The application of mathematics and scientific methods to military applications was called operations research to begin with. But today it has a different definition. It is also called management science. A general term, management science, also includes operations research. In fact, two terms are used interchangeably. A set of tools a set of tools that are used to solving problems is also called management science. Today, operation research is defined as a scientific approach to decision making that seeks to determine how best to operate a system under conditions or allocating scarce resources. In fact, the most important thing is operation research is the fact that resources are scarce and these scarce resources has to be used efficiently. Now the second portion in linear programming problem. This is a brief history of linear programming problem, which was first introduced by Danzig in 1947, and then in 1949 he introduced simplex method to solve linear programming problem. Next, I will discuss how to formulate linear programming problem, where I will try to introduce how to formulate real-life problems as linear programming problem and to understand the various terminology that is used in formulating linear programming problem. I will begin with linear programming problem with some example. Consider a small manufacturer making two products A and B. Two resources are required, that is R1 and R2, to make these products. Now each unit of product A requires 1 unit of R1 and 3 units of R2. Manufacturer has 5 units of R1 available and 12 units of R2 available. The manufacturer also makes a profit of rupees 6 per unit and of A sold and rupees 5 per unit of B sold. So this is the problem of setting that we are looking at. Now, what are the issues that this manufacturer faces? First, the manufacturer would like to produce in such a way that the profit is maximized. How does the manufacturer go around formulating this problem? The first thing is that the manufacturer has to decide the number of units of A and B that is to be produced. It is also reasonable to assume that the manufacturer produces A and B in such a way to maximize the profit. So first thing that the manufacturer has to do is to decide or determine how many units of A and how many units of B he or she is going to produce. So first call these as x and y. So let x be the number of units of A produced and y be the number of units of B produced. So if the manufacturer produces X units of A and Y units of B, then the money that the person makes or the profit that the person makes, which we call as Z, will now be 6x plus 5y. Now the manufacturer would ideally like to produce as much of A and as much of B possible. But what happens is the availability of these resources will now try to restrict the amount of A and B, that is X and Y, that the manufacturer can produce. So we look at the resource requirement of X of A and Y of B. So since each unit of A requires 1 unit of R1 and each unit of B requires 1 of R1, then the total amount of resources R1 required is X plus Y. What is available is 5. This is x plus y should not exceed 5 or x plus y less than or equals to 5. It cannot be more than 5. Similarly, 1 unit of A requires 3 of R2 and 1 unit of B requires 2 of R2. So, requirement to produce x unit of A, y and y unit of B is given by 3x plus 2y. This has to be less than or equals to 12. It cannot be greater than 12. Also, we need to explicitly state that this manufacturer will make X and Y which are greater than or equals to 0. That is, the person cannot produce negative quantities of both X and Y. Also, since the person wants to maximize the profit function Z is to be maximized. So this is the formulation that profit is maximizing 6x plus xy subject to x plus y less than or equals to 5 and 3x plus 3y less than or equals to 12. X and y are greater than or equals to 0, and this is the formulation of linear programming problems from the product mix problem. This is also called formulation of linear programming problem. Thank you.